This video is over how to solve inequalities. So let's look at our number routine. How do you know? Let me get my computer. A coach threw at least 30 balls. He has already thrown 16 balls. Write and solve an inequality to determine how many more balls he could throw. So let's see. A coach threw at least 30 balls. Like 30 is the least number of balls he threw. So that means he must have thrown more than 30. So like 35 balls. Would that make sense? At least 30. So 35 is a good number, but it includes 30. Yeah, at least 30. So we know we're going to be using greater than or equal to 30. So he's already thrown 30. We're figuring out how many more balls he can throw. So ball plus 16 has to be, so number of balls he can throw plus 16 is already thrown has to be more than or equal to 30. Now, so we wrote an inequality. It worked. Now we need to solve it. So again, to solve an inequality is like solving an equation. So we need to isolate the variable b. So you do the inverse operation of plus 16. Pen not working. So the inverse operation is minus 16, minus 16. Cancel. So b is greater than or equal to, what is 30 minus 16? 14. So let's graph this. So 14, 15, 16, 13, 12. Remember, a number line does go from least to greatest. So b has to be greater than 14 or equal to 14. So it can include 14, but it has to be greater than 14. Shade numbers are greater. So 16 is greater than 14. And let's check our work. If I added 16 to 16 as 32, is 32 greater or equal to 30? It is. So let's look at our do now. Tammy parent limit the number of text messages she is allowed to send each month to at most 100. So she's only allowed to send 100 text messages, the most she can send at most. So far this month, so bad for her. So far this month, Tammy has sent 64 messages. Write an inequality that can be used to find m, the number of messages Tammy could send for the remainder of the month. So let's think. So 100. 100 is the most she can send, the most. Can she send more than 100? No. But so that means she can send less than or equal to 100. So she's already sent in 64 already. But then we want to find how many more can she send. So 64 represents how many she's already sent, plus m, the number of messages that she can still send, and that number has to be less than or equal to 100. So we found our inequality. Could I rewrite this inequality? Yes, you can. What about writing it as m plus 64 is 100? For each of the following, indicate whether the value is a reasonable solution to the inequality for the situation by writing yes or no. So again, our inequality is m plus 4 is less than or equal to 100. So if I add 40 to 64, that would be 104. Can she send 40 messages? No, that's going to be over her limit. No. Can we send -3 text messages? Even though it does work, it doesn't make sense in reality. What about 30 text messages? Yes, that would be 94 or less. What about 35 and a half? No, you cannot send half of a text. It's either a text message or not. And what about 36? You add 36 plus 64 to 100. That is less than or equal to 100, so yes. So now I would like you to graph this. Now solve the inequality. So m is plus 30, m plus 64. Let me erase this. M plus 64 is less than or equal to 100. Again, how do you solve an inequality? You have to isolate the variable m. You do the inverse operation. So I subtract, cancel. So message, the remainder of the month, she can send less than or equal to 36. Send 36, but it has to be less than or equal to 36. Let's graph this. So it includes 36, 37, 38, 35, whoops, 35, 34. Remember, A goes from least to greatest, so she can send less than or equal to 36. So we shade less than 36 or equal to 36. All right, so what you're going to be doing in this activity is the following. We're going to be discovering more about solving inequality. So each person needs to roll a number cube. 1 and 2. So partner 1 has 1. Partner B has, so partner A has rolled 1 as a number cube, and partner B rolled 2. So which inequality would you use? We would use the 1 is less than 2. So now you choose an operation. If you add -2 to both sides, 1 plus -2 is -1. 2 plus -2 is 0. So which inequality? Is A still less than B? Yeah. Let's pick another one. If you subtract 2 from both sides, so -1 minus 2, that'd be -3. 0 minus 2 is -2. So is -3 still less than -2? Yeah. If you multiply by -3, so I multiply by -3, -3 times -3 is 9, and -3 times -2 is 6. Who's larger now? 9 is greater than 6. Divide by 1. If you divide by 1, it's still 9. If you divide by 1, it's 6. The 9 is still greater than 6. Multiply by -2. That would be -18. 6 groups of -2 will be -12. Which side is greater? -18 or -12? So -18 is less than -12. If you divide by -1, that would be 18. And divide by -1, that would be 12. So 18 is greater than 12. If you add 3 to both sides, it would be 21. And this will be 15. 21 is greater than 15. If you multiply by -1, it'll be -21. Multiply by -15, and which one's greater? -21, -15. Oh, -15. So we're going to stop right here. What pattern did you notice here? When did the inequality symbol reverse or flip over? Let's see. Let me use a different pen color. No, let me use a highlighter actually. It's less than, less than, less than. It flipped right here. It flipped again right here. It flipped again right here. And it flipped again here. So in what instant, or what operation did it started flipping over? Well, it never flipped over when we add or subtract. It did flip over when we multiply and divide. No, but there's a divide right here. But what do all these have in common? Multiply by -3, multiply by -2, divide by -1, multiply by hopefully you discover that when you multiply or divide by a negative, it flips the sign over. Remember a long time ago, we learned this. Negative, if you need to, you could go to past video. Remember, -3 times 2. 3 times 2 is 6. Negative means you're doing the opposite of 3 times 2. So it's -6. So it's like when you are multiplying by a negative number, you're doing the opposite of it. That also applies to inequality symbol. You're doing the opposite symbol. So it's flipping it around. So for example, let's do like divide by -1. 25 divided by -1. 25 divided by 1 is 25. Do the opposite, -25. So same thing here. They flip. So again, when you solve inequality, it's just like solving a regular equation. We do mostly the same thing, but you also must pay attention to the direction of the inequality. There are things we can do without affecting inequality. You add or subtract or multiply and divide by a positive number and simplify, nothing happens. But when you multiply, highlight this, is really important you understand this. When you multiply or divide both sides by a negative number, the sign does reverse. It does. So we're going to practice with two examples to see if this is really true. So let me get my calligraphy pen again. When you multiply -3 by -5, what do you get? 15. Is 15 less than or equal to 9? False. So scratch out -5. If you multiply -3 times -4, 3 groups of -4 and -12, but opposite is 12. Is 12 less than false? You scratch it. When you multiply -3 times -3, you get 9. Is that less than or equal to 9? It is. So I'll circle -3. When you multiply -3 and -2, you get 6. Is 6 less than 9? True. When you multiply -3 times -1, you get 3. Is that less than 9? True. When you multiply -3 by 0, you get 0. Is that less than 9? True. I think everything else will be it. When you multiply -3 by 1, it's -3. Is that less than 9? True. I can stop here, but -3 times 2 is -6, less than 9. Yes, true. -3 times 3 is -9, less than 9. True. -3 times 4 is -12. True. And -15 is less than 9. So as you can tell right here, at -3 and so on, anything greater than that, it works. But if it's -4 or less down there, it doesn't. Let's solve this. -3x is less than or equal to 9. So you same thing like you do with regular equation. You need to isolate this variable x. In order to isolate the variable, you do the inverse operation. What's the inverse of multiply -3? Divide by -3. Divide by -3. So this cancel. X, 9 divided by -3 is -3. Now, you are tempted to write x is less than or equal to -3. But look at your graph right now. Is that so true? Least to greatest. Or the numbers I circle, are they less than -3? They're actually equal to -3 and greater. So when you, let me erase this, when you are multiplying or dividing by a negative number, it reverses the symbol. Think of it as you're dividing by -3, you're doing the opposite sign. So the opposite of less than equal to is greater than equal to. So it is equal to -3 and all the numbers that are greater than -3. So x is greater or equal to -3. Let's look at another example. If you multiply -2 by y, it has to be greater than -6. So -2 then times -5 is 10. Is that greater than 6? Yeah. So I circled. -2 times -4 is 8. Is that greater than -6? Yes. -2 times -3 is 6. It's greater. -2 times -2 is 4. It's greater. -2 times -1 is 2. It's greater. -2 times 0 is 0. It's greater. -2 times 1 is -2. Greater. -2 times 2 is -4. It's greater. -2 times 3 is -6. Is -6 greater than 6? No. False. Scratch out 3. Negative 2 times 4 is negative 8. Is that greater? Nope, false. And negative 2 times 5 is negative 10. Is that greater? Nope, false. So looking at my number line, from what I can tell, anything that are 2 or less, it works. This inequality will work. Now let's solve it. Negative 2y is greater than or equal to negative 6. Again, we use a different pen color. We have to isolate the variable y. So you do the inverse operation of multiply negative 2 with divide negative 2. Divide negative 2. Let's cancel. Y is greater than negative 6 divided by negative 2. It's canceled. It's 3. Let's look at our number line, see if that reflects that. Is y, are all these greater than 3? No, these are all scratched out. Oh, when you multiply and divide by a negative number, the sign reverse. It does the opposite of it. So that means it has to be less than, look at this, all these are less than 3. So it doesn't include 3, but everything is less than 3. So again, think of it as you're doing the opposite sign, opposite. So we're going to practice with 4 or 5 examples. We're really good at this. So let's isolate this variable. So we solve for inequality. Isolate the variable c by doing the operation of plus 6 minus this cancel. C is less than 9. We practice 9, 11, 8, 7. C has to be less than 9. So that's it. But can't be equal to 9. So let's try another example. B minus 9 is greater than 2. Isolate the variable, the inverse operation, plus 9, plus 9. B is greater than 11, 11, 12, 13, 10, 9. So B has to be greater than 11. So least to greater, greatest greater. Let's check our work. 12. 12 minus 9 is 3 is greater than 2. Check mark, it works. I need to isolate the variable t, so I do the inverse operation. Opposite of multiply 4 is divide 4. Divide 4. Cancel. T is less than or equal to 4. 6, 3, 2. It has to be less than 4 or equal to 4. And let's check our work. 4 times 2 is 8. 8 less than 16. Check mark. Now, let's do the inverse operation. We need to isolate the variable h. The inverse operation divide times 3. 3 h is greater than or equal to 12. 12, 13, 14, 11, 10 has to be greater than 12 or equal to 12. Let's check our work. I'll use 15. Is 15 divided by 3 greater than 4? Yeah, check mark. Now let's get to the hard stuff. I need to isolate the variable t by doing the inverse operation of the inverse operation of multiply negative 8 is divide negative 8. Divide. So b is less than or equal to negative 2. Let's look at this one. Let's see if this really does work. Negative 2, negative 1, 0, 1, 3, 4. It has to be less than or equal to negative 2. Let's see if this does work. I'm going to pick a number here. For example, I'm going to pick negative 3. Negative 8. I'm going to check my work. Negative 8 times negative 3 is 24. Is that less than 16? No, it's not. So I did not graph it correctly, and this inequality is not correct. Let me erase this. Remember, this is saying you do the opposite of this inequality. What is the opposite of this inequality? It's greater than or equal to. So t has to be greater than negative 2 or equal to negative 2. So let's see this work. 0. Negative 8 times 0 is 0. Is that less than or equal to 16? It is. So when you're multiplying or dividing by negative, you got to reverse the sign. Flip it around. Ooh, n divided by negative 3 is greater than or equal to negative 4. So let's look at this. I see a negative right here. It's saying you need to do the opposite symbol. So let's do the inverse operation of dividing. Multiply, multiply negative 3. So n negative 4 times negative 3 is 12. But we do the opposite, less than or equal to. This, why is my pen not working? I have no idea. Well, it's supposed to be n is less than or equal to negative, n is less than or equal. I do not know why it happened.